Hello everyone, I am Annisa Pratiwi. In this video, I will explain the experiment video of refraction of light through a glass prism. What are our learning objectives? First, student can mention the Snell's first law. Second, student can mention the Snell's second law. Third, students can explain how light refraction in a prism is formed. And last, students can calculate the angle of deviation formed when the light refracts through a glass prism. What are our experiment objectives? First, to find out the Snell's first law on prisms. Second, to know Snell's second law on prism. Third, to know the beta angle in the prism. Fourth, to find out the angle of deviation in prism. The problem formulation is to analyze the relationship between the angle of the incident ray and the refraction angle formed. Theoretically overview. Before I show you the experiment, I'll explain the theoretically overview. This can be a hypothesis before the experiment. First, we discuss about the Snell's first law. Snell's first law states that the incident ray, the refracted ray, and the normal to the interface of two media at the point of incidence all lie on the same plane. Next, Snell's second law. Snell's second law states that the ratio of the sin of the angle of incidence to the sins of the angle of refraction is constant for the pair of the given media. Beta angle. The apical angle or beta of the prism is the angle between the two faces. When light passes through the prism, it is refracted at both surfaces. The emergent ray typically leaves the prism with a direction different from the incident ray. Deviation angle. Deviation angle is the angle formed between the incident ray and the direction of the ray leaving the prism or refractive ray. Theoretically, the magnitude of the angle of incidence will affect the magnitude of the resulting refractive angle. After discussing the theoretical overview, now I will show you the demonstration and the experiments. Tools and materials. First, there are prism and plane parallel, but in this video we only use the prism. Then, there is a bow and a ruler. Next, there is paper, needle, and styrofoam. Procedures experiment. First, provide the styrofoam. Then, place the paper on the styrofoam. Next, draw the triangular side of the prism. Next, draw the normal line of the incident ray. Then we determine the angle of the incident ray. Here I use 40 degrees. Then we draw the incident ray. Next, determine the refractive ray. First, puncture the needle along the incident ray. Then we can observe the refractive ray from the opposite direction to the direction of the incident rays. After finding the refractive ray, we stab the needle along the refractive ray found. Next, we draw the refractive ray according to the needle puncture marks along the refractive ray. Then draw the normal line of the refractive ray. It can be determined by measuring 60 degrees to the side of the prism, but intersecting with the refracting ray. Next, we draw the deviation line. And then, we determine and measure the required angles. Firstly, angle first eye, which is the angle between the incident ray and the normal line of the incident ray. The magnitude is 40 degrees. Next, angle first R, which is the angle between the deviation line and the normal line of the incident ray. The magnitude is 29 degrees. Next, angle second eye, which is the angle between the deviation line and the normal line of the refractive ray. The magnitude is 32 degrees. Then angle second R, which is the angle between the refractive ray and the normal line of the refractive ray. The magnitude is 64 degrees. Next is the deviation angle, which is the angle between the incident ray and the refractive ray. The magnitude is 37 degrees. Discussion. The beta of the practicum is known to be 60 degrees. Since the sum of the triangle angles is 180 degrees, the beta is 60 degrees. After determining the practical beta, we find the theoretical beta with the formula: if second I is equal to first R, then the beta formula is 2 times first R. Meanwhile, if second I is not equal to first R, then the beta formula is second I plus first R. Because in this practicum, second I is not equal to first R, the theoretical beta is second I plus first R. 32 degrees plus 29 degrees becomes 61 degrees. Because the practical and theoretical beta values are different, we must find the percent error. Percentage error is calculated by the formula theory value minus practicum value, then divided by theory value, then multiplied by 100%. 61 degrees minus 60 degrees equals 1 divided by 61 and multiplied by 100%. Then the percent error is 1.63%. Next, we determine the deviation angle, which is symbolized by delta. The practical delta is 37 degrees. The theoretical delta is calculated by the formula first I minus first R plus second R minus second I. Thus, delta equals to 40 degrees minus 29 degrees plus 64 degrees minus 32 degrees. Delta equals to 11 degrees plus 32 degrees. Then delta becomes 43 degrees. And the percent error is 13.9%. After calculating angle 40 degrees, we repeat the experiment with other angles such as 25-degree angle, 30-degree angle, 50-degree angle, and a 60-degree angle. After 5 experiments, we analyze the data as shown in the following table and graph. Conclusion. From this data based on the applicable formula, the magnitude of the angle of incidence will affect the magnitude of the resulting refractive angle. That is, the greater the value of the incident angle, the greater the value of the resulting refractive angle.
That's all. Thank you for watching.